Hello everybody, so in this video I'm going to introduce you to the modulus function. But before we tackle any examples, we need to understand what a modulus function is. It's represented as the variable, in this case x, between two vertical lines. And this is defined as the absolute value of x. So what this means is that it always outputs a positive value or 0. So for instance, if x is equal to 3, then the modulus of x is also equal to 3. However, if x is equal to negative 3, then the modulus of x must be equal to a positive value, positive 3. If x is equal to negative 1/2, then the modulus of x will be positive 1/2. So it's outputting the positive value in every case. But if we look at when x equals 0, well then the modulus of x is also equal to 0. So the modulus of x must always be greater than or equal to 0. And this works with inequalities too. If we say the modulus of x must be less than or equal to 6, and we say that x is equal to 5, well then the modulus will also be equal to 5, and clearly this is less than or equal. But we could also say that x is equal to negative 5, which gives us a modulus of positive 5. So we can define this inequality as x being less than or equal to 6, but greater than or equal to negative 6. So a modulus function works for individual values, but it also works for a range of values. So let's move on to our first example, where we're going to start by sketching the graph of y equals the modulus of 2x minus 3. So to sketch this graph, we need to consider two cases. In case 1, where y equals positive 2x minus 3, and in case 2, y equals negative 2x minus 3, because in both cases, y will be the modulus of 2x minus 3. Okay? So if we look at case 1, we have 2x minus 3. Well, we know that this will have a positive gradient of 2 and an intercept of negative 3. So we can show this on the axis. If we're saying that this is negative 3, and we give it a positive gradient, so something like this. So y is equal to 2x minus 3. And in case 2, we'll have a negative gradient, so negative 2x, but a positive intercept. So negative times a negative will make an intercept of positive 3. And this will look something like this, where this is y equals negative 2x plus 3. So the modulus function of 2x minus 3 can never be less than 0, which means it can never be below the x-axis. So the modulus will look like this V shape, where we go down to the x-axis, which is when it's equal to 0, and then back up. So to make it clearer, I'm going to dash this one and this one. And I'll label what's left as y equals the modulus of 2x minus 3. So I'll delete this as well. Okay? So now we have this graph, we can use this graph to solve the equations in B and C. So in question B, we're told that the modulus of 2x minus 3 is equal to 7. So y in this case must be equal to 7. So all we do is we draw a line at y equals 7, somewhere around here. I'll just carry on this graph through it, and you can see it will have two solutions at this value of x, which I'll call x1, and this value of x, which we'll call x2. So if we go back to our two cases, in case 1, 2x minus 3 is this line, so we can use this equation to solve this intercept. So to find x2, y, which is 7, will be equal to 2x minus 3. So we're finding this value of x here. We can add 3 to both sides, so 10 will equal 2x. So therefore, x2 will equal 5. Okay? So we'll say 5 and 7. If we look at case 2, we know negative lots of 2x minus 3 is here, so this will give us x1. So in this case 7 will equal negative 2x minus 3, so 7 will equal minus 2x plus 3. We can move the positive 3 to the other side, so we get 4 is equal to negative 2x, so therefore x1 must be equal to negative 2, which is this point here, negative 2 and 7. Okay? So do you want to try and solve question C, where the modulus of 2x minus 3 is equal to x plus 5? You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So for question C, we need to start by sketching x plus 5 on this graph. So we know the gradient of this line will be less steep than this gradient because 1 is less than 2. And we know it'll have a higher intercept of positive 5. So it will look something like this, where we have two intersections. We have a point here, which will give us x1, and we have a point here, which will give us x2. If we go back to our two cases, y equals 2x minus 3 is in this solution. So to find x2, we'll use case 1. So x plus 5 will be equal to 2x minus 3. So we get 5 is equal to x minus 3. And then we'll move a negative 3 to the left hand side. So x2 is equal to 8. And to find x1, we'll use case 2, which is this part of the line. So x plus 5 will equal negative 2x plus 3. Moving this negative 2x to the left hand side and this 5 to the right hand side, we get 3x is equal to minus 2. So x will equal negative 2/3. Okay? And this is x1. So thank you very much for watching. I hope you found that useful. If you did find that useful, please like and subscribe, and you can download a full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.